Hello, this is Kim McAllister, and I'm going to go over some basics on understanding statistics in research. And we're going to focus this more on the type of research that we will do for typical nursing research. Excuse me, studies. So the purpose of a statistical analysis is because we have our nursing practice based on evidence base, and we have to know how to carry out an analysis so that we can read and evaluate it. You also need to know something about statistical analysis before you begin to do your own research in the future, so that you know how to set up your study and the way that you're going to analyze the data that you collect. So when you're conducting an analysis of the data, you're going to first of all identify and manage the missing data. The sample is going to be described by the data. You want to look at how reliable the measures that you're using are. You're going to do an exploratory analysis and then an inferential analysis. So let's look at this all in a little more detail. Almost all statistical analysis are done on computers. Yay! I actually remember a time before we had these programs, and trying to complete all of this by hand was very laborious and took a whole lot of time. And fortunately, we have software such as SPSS and others that will do this for you. However, you've got to put all the data into the computer, and as you're entering it, this is generally when you'll find out what's missing. And if too much data is missing on a subject, then you may have to eliminate them from the study. So it's very important to try to capture all the data. And it's very important that the people collecting the data understand how important the data is and what needs to be done to prevent losing data or not collecting data. So any missing data that you have, because everybody has missing data, so any data that's missing has to be explained in the results of the study. So when you are collecting data, you want to get as much information as you can about the sample. You want to include demographic variables such as age, gender, maybe height, weight, whatever. It depends on what your study is. And you're going to use the central tendency measures that we discussed in the last lecture to explain age and some of the other variables. And you're going to use this to compare the study group to the control group. You need to report how reliable your measurements are. What instrument did you use? Did you use a survey tool? Did you create your own tool or use a tool that had never been used before? If that's the case, then you're really going to need to conduct a pilot study and maybe several before you get any real reliability on the tool. Otherwise, people are not going to see your study as valid. You want to figure out how you're going to determine the reliability during the data collection process, part of the study. And your reliability measure depends on what measure that you use. You're going to do an exploratory analysis by looking at all the data descriptively, so describe what you have. You're going to use your central tendency and dispersion, as we discussed in the previous lecture, to identify your outliers and your variability. And remember that your outliers are the extreme ends of your data points. So after you have collected all the data, it has to be analyzed, and then we have to determine if they're significant. And so we do this through analysis. We have inferential analysis, which helps us generalize from the sample that we have collected and studied to the rest of the population. And if your study has been rigorous and you have an effective design, then this is much easier to do. And you want to include whatever type of analysis you use. So there's some different types of tests that we're going to talk about at the end of the lecture, and you would want to describe which ones you used. We want to look at probability theory versus decision theory. The probability says how likely is the data if the null hypothesis is true, and it indicates if the difference happens from random sampling. And this is expressed as a lowercase value, a lowercase letter p, and will vary from 0 to 1. So what does this mean? If you have a theory and you propose it that patients who receive an indwelling catheter during hospitalization have a higher UTI rate than patients who do not. Your null hypothesis states that there is no difference whatsoever in UTI rate between indwelling catheterized patients and non-indwelling catheterized patients. So how likely is what you observed with your data true if the null hypothesis correct? If it is 5% or less likely that what you observed with your data is true if the null hypothesis is correct, then you can reject the null hypothesis. So if there's a 5% or less chance that the null hypothesis is true, let me say that again. If there is a 5% or less likelihood that your data is true if the null hypothesis is correct, then you can reject the null hypothesis. Okay, look at that carefully and take that in so that that's not confusing. Okay, so just because your probability, your p-value is less than 5%, that doesn't necessarily mean that the hypothesis is correct. You need to replicate your study before it's considered truly significant. So you can carry out your study and you find something that looks like it is statistically significant. It's better to replicate it a few times so that we know that this really is something. So in order to determine what the statistical significance of the study is, we have a variety of tests that we use. And again, we'll talk about those at the end of this lecture. So when you want to look at probability theory versus decision theory, we already talked about probability. Let's look at decision theory. Decision theory assumes that all the groups in the study come from the same population. This is expressed as a null hypothesis that says there is no difference between the experimental group and the control group. So it's assuming that the experiment did not cause the change. Whatever change there was didn't happen from the experiment. So statistical significance is the probability of rejecting the null hypothesis when it's true. You want to conclude that a difference exists, or concluding that a difference exists when there is no difference, and it's noted as an alpha or a small a for absolute. And for the purposes of nursing studies, this is usually 0.05 or 5%, less than or equal to 5%. The lower the A value suggests that the sample provides enough evidence to reject the null hypothesis for the entire population. So the lower it goes, the more likely it is that you can reject it for everyone. So if an alpha value is absolute, so that means if the value is 5.1%, then there's no meaning to the differences. There's no statistical significance. And that can be difficult for some people to wrap their head about because it's like it's almost there. But we have an absolute cutoff. We don't go beyond that. So descriptive analysis rather than inferential analysis helps to describe or display the data in a meaningful way. And we look at measures of central tendency. We also look at spread, and there's no uncertainties about the values. Here you'll see the distribution of a normal curve. Now, understand, first of all, that there's never a normal curve in research. This is if everything is absolutely perfect, which never happens. And you can see this is the center of the normal curve. Tailedness is the degree to which the distribution in the graph is pulled to the left or the right of the normal curve. And so this gives you some kind of idea about the dispersion of the group or the characteristics being studied. So variability means how far out a group of scores is around the mean. Again, in the other lecture, we talked about how other things are determined by the mean and variability is. Remember that you find the variance, the variability, by subtracting the score from the mean. So you find how far away it is from the mean. If it's heterogeneous, again, you have the wide variety of data, and homogeneous, it's very similar. This is a little review from the other presentation, but I want to bring it along with us. And the range is the difference between the maximum and the minimum score. And because it's based on the two furthest outliers, it makes the data set can be unstable. The semi-quartile range is the range of the middle 50% of the data, and this tells us the spread or the dispersion. Variance is the spread or dispersion of the scores. You want to use an interval or a ratio level of measurement, and this is only compared with data using similar values. And so you could use that like with blood glucose or scale measurement of weight, and then you can see how it varies. We already talked about where the standard deviation comes from. You find the variance of your scores, you square those, and then you're going to calculate the square root of the variance. And percentile, remember, percentile is everything that is at or below the score, the amount that's at or below the score. We have a rule of 68, 95, 99.7, and that means 68% will fall within one standard deviation of the mean. 95% of the data fall within 2 standard deviations of the mean, and almost all the data will fall within 3 standard deviations of the mean. The coefficient of variation is a percentage used to compare standard deviation when the units of a measurement are different, or when the means of the distribution compared are far away. It's the ratio of the standard deviation to the mean, and it really helps you see what the degree of variation is from one data set to another. Now we want to talk about type 1 and type 2 errors. A type 1 error means that you rejected the null hypothesis when it's true. Okay, remember, the null hypothesis means that there was no change. So with a type 1 error, you said that something was true, that there really was change when there wasn't. A type 2 error is failing to reject the null hypothesis when it's false. So there was a change, but you rejected the null hypothesis when it was false. So when a null hypothesis, this is just a chart that helps. The researcher decides to reject the null when the null is true, that's a type 1. When the researcher rejects the null when the null hypothesis is false, that's a correct inference. When the researcher accepts the null when the null hypothesis is true, that's a correct inference. When the researcher accepts the null when the null hypothesis is false, this is a type 2 error. So this chart I think is very helpful in figuring out the difference between the two. So the only limitation that we have with descriptive statistics is that it doesn't really allow for conclusions to be drawn about the hypothesis. Inferential analysis allows you to examine relationships and makes predictions, find causalities or differences in studies. Understand that there's not a cut and dry statistical procedure for every type of situation. You've got to, when you prepare a study, there'll be several different types of procedures or analysis that you can use, and you just have to decide what is, what's going to work best for you. So inference is a conclusion based upon the evidence. When we generalize, that's when we can take the information from a specific situation or a study and apply it to other situations or to the rest of the population. Understand that having an inference as a conclusion based on the evidence, or the fact that what we have done is generalized and we see it in the bigger population and the population as a whole and not just the sample, that still doesn't tell you that you're 100% correct, because nothing will tell you that you're 100% correct. So there are different types of inferential analysis that you can use, and we're going to talk about those very quickly. We can do a chi-square. This is a test that tells us if two variables are independent or related. You're going to use nominal or ordinal data, and the problem with this is that your risk for type 2 error is high. An example is we used a chi-square to look at the differences between two groups of nurses. They were divided into a group with a low and a group with a high psychological distress. And we used three work variables: effort-reward balance, high psychological demand, and elevated job strain. And so you can do the chi-square to find the different groups. A t-test can be used to assess the means of if the means of two groups are statistically different from each other. So in this example, we did a study to look at the impact of a 12-week exercise program on a variety of measures: efficacy, pain, body weight, so on and so forth. And the group was placed on a 12-week exercise program, and then post-tests were conducted. So the control group did not do any exercise. And then you can do a t-test, and the results will show what the improvements are. ANOVA is analysis of variance, and just like it says, it's looking at the difference in variances rather than looking at the actual means. And this can tell the difference between three or more groups, and it's reported as an F statistic. So an example that we would use that for would be a study to compare obesity and cholesterol in children from 4 different countries. And they used ANOVA to find the difference between height, weight, BMI, and so on. The Pearson product moment correlation looks at relationships between variables, and data is collected from one sample, and it measures of both variables must be available for each participant in the data set. So if you have conducted your study and you're missing data from one of the participants, then they would not be able to be included, because you've got to have both variables available. So the results are termed a coalition coefficient as a value between -1 and +1. If there's a value of 0, then there's no relationship. An example was conducted to compare relationship of obesity and cholesterol. So we're looking at the relationship. Does obesity and cholesterol, is there a relationship between it? And this was to correlate and compare the 2 risk factors for cardiovascular disease. And researchers correlated BMI with cholesterol with the gender in 3 countries. And it shows that the relationship between BMI and cholesterol may vary by culture, gender, or ethnicity. You can also use a regression analysis to predict the value of one variable when the variable of one or more variable is known. It explains the variance in the dependent explains the variance in the dependent variable. Y is the dependent variable and X is the independent variable. And then you'll get a result that looks something like that. And you see where it all alters along the line, the intersection. Linear and multiple regressions. Linear is used when one independent variable is describing another. Multiple is when you're looking at two or more independent variables. So an example of a multiple regression would be a study conducted to determine how predictive job characteristics were of self-care adherence. And the regression predicted a dependent variable, which was self-care behavior, using the independent variable, job demand, job control, and so on. And the study identified 3 independent variables, which were physical functioning, psychological job demands, and workplace supervisor support that were significant for adherence behavior. So when you're interpreting the results of your study, you want to know that there are a variety of different results that you'll see. If it's significant and predicted, then it agrees with the results that were predicted by the researcher. If it's non-significant or insignificant, a negative result may be the reality, so the null may be true. If it's significant and unpredicted, then it's still significant, but it's different from what was projected by the researcher. Mixed results are most common. One variable may have a predicted result and the other does not. Very rarely do you conduct research for just one variable. So you can have results with one can be significant, one may not. Unexpected results happen when you have a relationship that was found between the variables that were not expected. Understand, especially in nursing research, you want to think about clinical importance versus statistical significance. Clinical importance means that there's a practical relevance of finding to practice. And significant results agree with the predictive outcome and support the framework. So strong studies for nursing are going to have both. They're going to be clinically important and statistically significant. Some studies could be statistically significant but have no clinical importance. So some final terminology. Limitations are problems that may impact the generalizability of the results. So problems that may keep the study from being applicable to everyone else. You always want to identify your limitations and include those in the study. There will always be limitations in any study. Your conclusion in your study is a synthesis of your results. So you're going to talk about what the results were and put all of that together into what it means for practice and what future study, what additional research needs to be done. Generalizing the findings is applying the findings of the sample to the population. Implications for nursing, you want to explain what this study did for nursing. How does this impact nursing practice? Did it change anything? Did it say we need to keep doing the same thing? What is that? What did this do for our body of knowledge, for our profession? All right, so I hope this has been a good basic introduction to understanding the statistics in research.